Okay, Unit 7, the logarithm chapter. Lots of fun here. Okay, so remember our squish and flip. Now the nice thing about this is you can try, and if you make a mistake, you can check with the squish and flip. So I'm converting to logs, which means your answer should have the word log in here. If you don't have a log on 8 through 11, you did something wrong. Now, the base is the base is the base. It's all about that base. So here's the base, and here's the exponent, right? Well, the base of the log goes here. That's why we say log base 10. So, now, think about it. We know we have an equal sign. Let's just swish and flick in our head. We know it's b to the h equals e. So let's just help ourselves. B to the what? Oh, h equals what? E. And we're done. It's that easy. 9, write log. What's my base? 3. Put the equal sign. If the arrows help, 3 to the what? X equals what? Y. Finished. Write log. What's the base? K. Equal sign to the what? M. Equals what? W. Number 11. Log. What's the base? P. Equal sign to the what? 4. Equals what? J. That's all. 12 through 15, you should not have log in the answer. And before we even jump into this, I'm going to write my little e here, because the base of any ln is e. I'm going to write a 10 here, because that's the base there. If we don't see it, it's log 10. Now, switch and flick. 3 to the what? Equals what? Boom. E to the 7 equals x. 8 to the x equals j. 10 to the what? 2 equals 100. And that's all you got to do. Okay, now this section blew a lot of people's minds. These are just the definitions we start off with when we learn this chapter. It's just the properties in an abstract way. So for number 16, I'm going to come back to that. So I'm just going to come to a new page real quick. And I'm going to say log 2 to the third equals 8. I think everybody can agree with that. 2 cubed is 8. 2 cubed is 8. Well, I'm going to rewrite this. Log base 2 to the 3 equals what? Instead of writing 8, I'm going to write 2 to the 3. So let's switch and flick. 2 to the third equals what? 2 to the third. So let's come back to our problem. B to the what equals B to the m. It's just m. B to the what is 1. Anything to the 0 power is 1. Now, you should recognize ln is just equal to 1, but if we wanted to, we can put a little e here, and e to the what is e. E to the first power is e, but ln is just 1. Same thing, different letter. B to the what is b? 1. 20 is an expansion problem. Okay? We're expanding. Log b to the m minus log b to the n. Division means subtraction. Now this is a combined problem, or condense, sorry. Condense. So we're only going to write log once. And it's log base b. And plus means times. So that just means x, y. There's no exponents, we're good. And then this bad boy has an exponent, which we move out in front. So that's n log b of m. And that's just to remind ourselves that exponents go out in front of the logs. That's it. It's just theoretical to help you understand what's happening when we do this. Okay. Calculator, heavy lifting. Let's make life easy on ourselves, right? Log 5, 625. Okay? All you have to do is go to math and go up a few. Log base right there. 5, arrow over, 625, enter. 4. Now, technically, what does this mean? 5 to the what power is 625? Well, 5 times 5 is 25. Times 5 is 125. Times 5 again is 625. Again, this one, 10 to the what is 0.001. Well, 0.001 is really this. So you could do this without the calculator if you think about it. What would make 10 become 1,000? Cubed. 10 cubed. But if it's on the bottom, it's going to be negative 3. If you want to try it and then confirm it, go ahead. Hit the log button. You don't have to go to math log base because it's just a base of 10. And just put 0.001. Oops. Try it again. Log 0.001. Enter. There it is, negative 3. Okay, 2 to the what is 1/32. Well, you can think about this. 2 to what power is 32? It's 2 to the 5th, right? And if it's on the bottom, it's going to be negative 5. But you've got the calculator to check you. And we're going to go to math, log base, and we're going to put a 2. And over here, we're just going to literally put in 1 divided by 32. There it is, negative 5. Now this one's kind of a tricky one. 9 to the what power is 3? We're getting smaller. 3 is the square root of 9. And remember, the exponent for that is the 1/2 power. 9 to the 1/2 is 3. But you can confirm here. Math, log, base. 9, arrow over, 3, enter. There it is, 0.5, 1/2. 27, 6 to what power is 1? It's 0. Whoops, you can do that. It's 0. You can confirm with the calculator if you want. Math, up. Any number here that becomes 1 is because it went to the 0 power. 28, 8 to what power is itself? That's 1. Okay? Again, you can confirm with the calculator. Math, log base. Whoops, wrong one, sorry. Math, log base. Enter. 8 over 8. Enter. 1. Okay? This is kind of like the one up above. B to the 4 is B to the 4. That's just like number 16, really. Except it has a number instead of another letter. This one's kind of confusing, and if it messes you up, don't let it. Use the calculator. Watch. This time it's 2 to the power of, and now I hit math, log base, and look, it looks just like it. 2, 9. And it's 9. This again is another theoretical one. But it's 9. Let the calculator help you out if you get into a jam. Okay, now this one, there is no, if this was a 9, it'd be easy. It'd be 2. 3 squared is 9. We don't have an easy answer. So we go to math, log base, and we put in 3, 8. And we get a long decimal. And it says round to the nearest 10,000th. That's 4 places. So that's 1.8928. Remember, this is a 10 right here. 10 to what power is 36? Well, let's think about it. 10 to the first is 10. 10 squared is 100. It's going to be 1 point something. Let's let our calculator help us out. Math, log base, 10 to the 36. And there it is. 1.5563, rounded out to 4 spaces. ln of 7, literally just hit ln 7. There you go. 1.9459. Log 419. Math button. Whoops. What happened there? Math button. Again, third time's the charm. Math button. 4, 19 in parentheses. Bam. There it is. 2.124. It's 0. Now we're expanding. Remember, when we expand, we're going to write log more than once. Not lag, log. Now let's think about this. We have 8 times x squared. There's no dot, but that's what it means. You can think about it in parentheses. Divided by y cubed. This is going to be very important when we're expanding, because we're going to write log 3 times. Now it's log 8 times x squared. So that's going to be plus, times becomes plus. And remember, what happens to exponents? It moves in front of the log. And then division means subtraction. Exponent moves in front of the log. That's it. What's happening here? We have 6 times x to the 5th times y squared. So we're going to write ln 3 times. ln of 6 plus, move the 5 in front, ln of x, plus, multiplication becomes plus, move the 2 in front, ln y. Again, we got 3 things going on here. 2x to the 9th and y. So we're going to write log 3 times. Log base 7 of 2 plus log base 7, I screwed up, because we have an exponent. And that exponent has to come out in front of the log. So it's 9 log base 7 of x plus log base 7 of y. Looks like loggy, but it's not. And last but not least, we have 1, 2, 3 things going on. Exponent's going to come out in front. So that's 3 times log base 5 of x plus 2. In parentheses, leave it alone. Minus log base 5 of 6. Minus, the 4 comes out in front, log base 5 of y. Moving on. Oh, not there. Here we go. Condense. Now remember, with condensing, we're only going to write ln once. Only once. Plus means times. So we're going to multiply this times this, and this is going to become the exponent. So this is really x squared right here. So it's just 4 times x squared, and you're done. Exponent, exponent. This means division, so I can just put a division symbol right there, a fraction mark. I'm going to write log out in front, only once. Don't write log on top and bottom. 1 log, and you condense. X to the 4 goes on the top, y to the 7 on the bottom. Okay. Notice we have 2 logs. This 2 is the exponent of the 5. This 3 is the exponent of the x plus 1. The minus means division. I'm only going to write log base 4 1 time. And on the top, I'm going to put 5 squared. And I'm just going to simplify right there because I know 5 squared is 25. And on the bottom, I'm going to have x plus 1 to the 3rd power. 42. 1, 2, 3 things. This 6 is the exponent of the x. 3 is the exponent of the y. x to the 6. I'm going to put ln out here in front of my fraction. X to the 6 goes on top. Everything else goes to the bottom because it's being subtracted. So y cubed and z. But we only write ln one time. Okay, find the inverse. We're going to swish and flick and switch the x and the y's. You can also switch the x and the y's first off. Doesn't matter. Let's do that if you want. X equals log base 8 of y. And now I'm going to switch and flip. 8 to the x equals y. If we did it the other way, we would have done 8 to the y equals x, and then just switch the x and the y. Same answer. So in other words, let me do it that way now. It doesn't really matter. Three to the y equals 2x. Divide by 2. X equals 3 to the y over 2. And then switch the x and the y. Y equals 3 to the x over 2. So you can see it doesn't really matter when you do it, switch first or not. 2 to the y equals x plus 1. Move the 1 over. 2 to the y minus 1 equals x. And then switch them. Y equals 2 to the x minus 1. Okay. 46, we have the same bases. They're gone. It's simply 2x plus 3 equals 4x minus 1. At which point, I'm going to subtract 2x from both sides and get 2x over here. I'm going to add 1 to both sides and get 4. Divide by 2, x equals 2. Now here, I can't just cross them out, because I need to rewrite this 64 as 4 to the something. Well, 4 squared is 16, 4 cubed is 64. But I cannot forget this x minus 4 equals 4 to the x plus 2. At this point, I can cross out because I have the same bases. I'm going to distribute my 3 and get 3x minus 12 is equal to x plus 2. Still seeing a lot of errors on these types of problems in the reviews. You have to have the same bases. And if it helps you, just come off to the side and rewrite this as 4 cubed. And then move it in and put your parentheses around the rest of your exponent. I'm going to subtract x from both sides and get 2x. I'm going to add 12 to both sides and get 14. Divide by 2, x is 7. Okay, now this one I need to log both sides. Remember, this is going to go out in front of my log. So 2x log 3 equals log 11. I want to get x by itself. So I'm going to divide both sides by log 3. At this point, use your calculator. Log 11. Close these parentheses. Don't forget that. Divided by log 3. I get my answer right here. But remember, that's 2x. 2x is equal to that. So I'm going to divide by 2 and get my answer. X equals 1.0913. Again, if you wanted to, you could have written out 2x equals 2.18265. 2.18265, and then divide by 2. Or just do it with a calculator. It's up to you. And 49, we're going to ln both sides. So remember, the x is going to go in front. So ln of 142 is equal to x times ln e. Remember, what is ln e? That's just 1. So basically, x is just ln of 142. you literally just type in your calculator, ln 142, enter, and get 4x equals 4.9558. That's all. 50. Switch and flick. 5 to the negative 3 equals x. You really don't need to go to the calculator on this one. Just remember, negative means it's going to be on the bottom. 5 cubed is 125. Okay? If you do some calculated, the problem with this one is 5 to the power of the negative 3, you get a decimal. Now, you can turn this into a fraction by number 1. That's turned into a fraction. There it is. 1 over 125. 51. Notice, I have log 3 and log 3. Those can go bye-bye. But here's the thing. This does not mean 1/2 of 64. Remember, this is the exponent. This means x equals 64 to the 1/2 power. Now you can type that in your calculator, or just remember the 1/2 means the square root. So x is 8. So again, if you want to confirm, nothing wrong with that. 64 to the 1/2, whoops. You can type in 1 divided by 2, and it's 0.5. There it is, 8. ln, remember, we don't have anything, it's e. Switch and flick. X equals e to the 3. Where's that? It's above the ln in blue. So we get second ln, there's your e, put a 3, and there's our decimal. 20.0554. 53. 6 squared equals x minus 4. Switch and flick. So 36 equals x minus 4. Add 4 to both sides, and we have 40. Okay, we have an ln on both sides. We just cross it out. X squared equals 2x plus 3. I'm going to move both the 2x and the minus 3 plus 3 to the other side by subtraction. And now I just guess and check factoring. X times x, 3 and 1. I want more negatives. X equals 3 and negative 1. Log 2, they're gone. It's 6x minus 1 equals 2x plus 1. That's a horrible plus. Okay, I'm going to subtract 2x and get 4x. I'm going to add 1 and get 2. Divide by 4. X equals 2/4, also known as 1/2. Log 7 gone. Don't forget, this is the exponent. So it's just basically x equals 16 to the 1/2, also known as the square root of 16, so x equals 4. Now, here is one that really caused a lot of people headaches on the test in this section. Oh, I'm going to get rid of the ln's. And they do this, x plus 4. No. Remember, when you want to condense first. Condense first. So I'm going to condense this side to ln x times 4, 4x, equals ln 2 to the 3rd. Now I can get rid of my ln's, and I have 4x equals 8, x equals 2 by division. Okay, last page on this section, and it's a little bit longer. Okay, we have our formulas. We have our interest formula, compound interest. This is money. Okay, so this one's money, this one's money. Now, I'm not saying you can't have money problems a lot of times with the next two, with decay and growth. You do. But these are investing problems usually. Remember, E is continuously. Continuously. If you see the word continuously, or you see words like tripled, or doubled, or quadrupled, you're going to be using the E. And then this is growth, this is decay. So, on 58, we're doing it 3 times. 3,000 is our principal. This is our rate, and this is our time. So quarterly, future amount is going to be equal to that 3 grand times 1. Now, this would be plus the rate as a decimal, 0.035, remember, to the left, divided by n. N is our compounding period. That's quarterly, so that's 4 times. And then n times t, 4 times 6. Now, when I do this in the calculator, I like to take baby steps. So what I do is I start in the middle, inside. I do 0.035 divided by 4, plus 1. I work backwards. To the power of 4 times 6, 24, times 3,000. I work backwards. You can put it all in one fell swoop, but you also might have an error by having parentheses in the wrong place or something like that. So how much money is that? Whoops. It ends up being $3,697.66. Now, semi-annually is going to look almost exactly the same. A equals 3 grand. 1 plus 0.035 divided by semi-annually, twice a year, 2 times 6. So the only thing that's going to change is, now I'm going to do 0.035 divided by 2 instead of 4, plus 1, raised to the power of now 2 times 6, which is 12, times the 3 grand. And there's my answer, $36.94 and 32 cents. Careful, the 7 makes the 1 round up. And then continuously, A equals the principal amount, 3 grand. Then there's the E, and then the rate, 0.035, and then time, 6. This one really hurt people on the test. I had people underline the word continuously and still use this formula. You can't use that one. You don't have an n. You don't have a compounding amount. It's continuously. So if you do this one on the calculator, we just type in 3,000 times E, and then you can do it off on the side, or you can literally in parentheses put 0.035 times 6. Those parentheses. There you go. 37.01 and 3 cents. Larry bought a mower. Here's the equation. Here's our principal. Here's our future amount. Now, here's the tricky part. This is already calculated for you. Remember, this has to be either 1 plus a number or 1 minus a number. Well, think about it. 0.9 is less than 1, so it can't be growth. It must be decay. Not to mention, look, if you start off with $7,500 and you end up with $4,428, it's dropping in value. So you know it's minus. So what taken away from 1 will give you 0.9? Think about money. 0.9 is 90 cents. 1 minus 10 cents is 90 cents. Okay? So that is our decay right there. Sorry about that. Ooh, I almost hit snooze it. Okay, I don't want to do that. So, how much did Larry pay for the mower when it was new? $7,500. What was the annual rate of depreciation? 10%. 1 minus 0.10. Alright, number 60. Again, here's my principal. Here's my rate. Here's my times it was compounded, which means monthly. And here's my time, years. So what's the interest rate? 0.06 as a rate, 6%. To the right, to the right. How much is the initial investment? We said that, $8,000. How often is it compounded? That's N. 12 times, also known as monthly. How long will it be in the bank? That's time, 5 years. Golf club, depreciate 22% each year. Original value is $1,400. How much in 3 years? Well, how much if it started off at $1,400 and depreciating by 22%, 3 years? That's our decay formula right there from the top. Notice there's no compounding time. And we just calculate that. So I type in my calculator. 1 minus 0.22 equals raised to the third power times $1,400. And you should get a number smaller because it's going down in value. So that's $6.64.37. Now, when will it have a value going 200? Well, now we're going to end up logging. Here's our future value. Same formula, 1 minus 0.22, which we might as well just make it easier. That's 0.78. To the power of t. We don't know the time. So first off, we're going to divide by 1,400. And that's going to give us a nasty decimal. So to get the most accurate answer, I'm just going to say, that's gone. I need to log both sides. So log, I'm going to keep it as a fraction to get the most accurate answer. 200 divided by 1,400 is equal to t log 0.78. Now, what do I need to do to solve for t? I need to divide both sides by log 0.78. Log 0.78. So what I'm going to do on my calculator is type in log of 200 divided by 1,400. And instead of rounding that and then divide by log 0.78, I'm just going to go ahead and divide right now by log 0.78. And that gives me about 7.8 years. Okay, so identify these. Growth or decay? Well, this is over 1, so that's growth. Just for the heck of it, that's a 16% growth rate. 1 plus 0.16. This is less than 1. 1 minus 6 cents would give us 94 cents. So that's decay. And just for the heck of it, that's a 6% decay. 3/4 is really 0.75, which would be 1 minus 0.25 decay at a 25% rate. 0.88, again, that's 1 minus 12 cents. So that is decay at a rate of 12%. And last but not least, 5/2 is 2.5. Well, that's 1 plus 1.5. So that's growth. And that's actually 150%. Big growth rate. And that's it for this unit.